I was interested in learning the programming language Go. Why? Well, not only does it have the best mascot of any programming language, but because it's got great performance comparable to C++, good for working with web servers and APIs, simple to use, and because the program's compiled to a simple binary, it's easy to deploy on different systems. In my experience, the best way I've found to learn a new language is to first watch a video explaining the basics of that language, things like the syntax of variable declarations, for loops, data structures like arrays, etc. I personally watched this video by Alex Mux, which is perfect for anyone with previous programming experience, so it contained all the information I needed. If you're also interested in picking up GoLang, I highly recommend checking his video out first. Now to the actual programming. My first beginner project is going to be a simple to-do list program in the terminal. Initially, I want to be able to add tasks, save them in JSON, list all saved tasks, mark them as done or completed, and remove tasks, either one or many. All Go projects begin with a module, which defines the root of the project and manages dependencies. Inside a module, we organize code into directories called packages. Each package contains one or more Go source files. So, to start a Go project, I begin by creating a module using the go mod init command. Then creating the entry point for our program as the main.go file. I'll be using the popular Go library Cobra for this project, so I'll create a CMD package to organize the code with each CLI command defined in its own file within that package. The project needs two more packages, todo and data. The todo package will have the core task struct and logic for creating, sorting, and saving tasks. The data package will simply hold the JSON file containing the information for the saved tasks. Tasks is getting hard to say over and over, so I'm going to be saying to-dos instead. Main.go is the entry point of the program and simply calls command.execute to start the CLI. Root.go is the first file executed. It imports the Cobra library and defines the root command. The execute function runs root command and prints any errors to the console before exiting. The first subcommand we'll implement is add, which will allow users to create new to-dos. Implementing commands with Cobra is pretty straightforward. We define the command's use, short description, expected arguments, and the logic to execute when the command runs. The final step is to write an init function that registers the new command with the root command using rootcommand.addCommand and then the name of that command. This step is crucial. Without it, the command won't be recognized by the CLI. The init function is also where we define any flags associated with the command. todo.go is where we define the contents of a new to-do object or struct, and also how to initialize a new to-do. Also in the to-do package, we need to define how to store the to-dos to JSON. We'll do this in our new storage.go file. After saving the to-dos to JSON, we also need to know how to load them from JSON. This is where our load tasks function comes in. After fixing any residual problems left in the code, we can compile the program and run it and test it out. The command go run and then the program name compiles and then runs that compiled binary of our program. Running the program gives the help information, but we can also use our subcommand add with the name of the to-do, and right there it says it added. But we can also check inside of our JSON file to see our saved task. After completing this first subcommand add, we can scale that really easily into other commands such as list and done and get those implemented. After completing the list and done commands, I'm now testing them out in the terminal here and realizing that for some reason I can't get the done command to work. And then I see it's in the root command .add command, part of our init function for that command. It's adding list twice, as you can see there in the terminal. After getting the done command finally added, I'm just here testing the edge cases for that command to make sure that they're all handled correctly. The next commands that we're going to implement are remove and clear. Remove is for removing one task at a time, and clear is for removing all of the tasks that are currently saved. Because this is a repeat of pretty much the exact same code as the other tasks, I'm just going to skip until it's done. The clear command works in the same way as the remove command, but without any input validation. It simply clears all the to-dos. Well, that's all for this video. In the next one, we'll take this CLI a step further by turning it into a colorful terminal user interface, or TUI, using the Bubble T and Bubbles libraries.